Good day everyone, I'm Teacher Daisy and today I will be your first lecturer for the first episode of Calculus Speaks. So for today's episode, I'll be talking to you about the basic concepts of polar coordinates.
But first, let's review the Cartesian coordinate. We have already worked with it before when we plot x and y on a plane, wherein x is telling us the horizontal displacement from the origin, while y is telling us the vertical displacement from the origin. For example, let's try to locate the coordinate 3 and 2. When we start placing from the origin, we will have 3 units going to the right and 2 units going up. When we use the Cartesian coordinate, it is easy for us to locate a point by using the horizontal and vertical lines or the x and y values. But this is not the only way to define a point in two-dimensional space. Instead of moving vertically and horizontally from the origin, to get the point, we could go straight out of the origin until we hit the point, then determine the angle these lines make with the positive x-axis. So we can have r as the radial distance from the pole or origin, and theta as the direction measured from positive x-axis moving counterclockwise. Observe that when we measure the radians, it was noticed that there is a redundancy. Looking on the positive x-axis, it can describe as theta equal to 0 or theta is equals to 2 pi. Theta and theta plus k, 2 pi, represent the same direction of all integers for all the values of k. So here's an example. Let's locate the point 4 and pi over 3. Our radial distance from the pole is 4, and our direction is pi over 3, measured from the positive x-axis. So here is the point. But it is important to note that polar coordinates are not unique. In Cartesian coordinate, there is only exact one set of coordinates for any given point. But with polar coordinates, this isn't true. So let's explore this example. Here's how we originally see the point. Pi over 3 radians from the positive x-axis, measured counterclockwise, and 5 units away from the pole. But we can add 2 pi to the direction coordinate, that means with a circle around, and arrive at this direction and move 5 units from the pole. So we have the coordinate 5 and 7 pi over 3 are also polar coordinate of the same point. But we can also subtract 2 pi from the direction coordinate and obtain negative 5 pi over 3. In this case, we can travel 5 pi over 3 clockwise from the x-axis and 5 units out again at the same point. So here's another possibility: we could add pi to the coordinate pi over 3. By doing so, we are pointing to the opposite direction. That might be a problem, except if we let our r to be negative. So it is the non-standard way to do it. Usually, when you are describing point in a plane using polar coordinate, we try to use positive values of r. But it is also important to know if what happens when r is negative. So here are just proofs that describing a point in a polar coordinate is non-unique. There are infinite ways to describe points.
Thank you for being with me. I hope that you are now knowledgeable and excited to explore more about the polar coordinates.